Hello everyone, welcome back to channel. So today we are making a video based on the friction. So in the friction chapter there are two kind of problem. First kind is horizontal plane and second type is inclined plane. So in this video I will make a video based on the inclined plane and we'll solve this numerical which is in front of you, and we'll make it so simple that you will enjoy this video and you will never make a mistake while solving this kind of problems. So watch this video till the end. So the given question is, what should be the value of theta so that the motion of block A impends down the plane? The coefficient of friction mu for all surfaces by 3. Mass of block A is 40 kg. Mass of block B is 13.5 kg. Now these are the given parameters. Now see, block A is kept on this inclined plane. The angle of inclined plane theta is unknown. Now this block B is kept on the block A, and block B is connected to this wall with the help of this cable. With this given information, we'll try to draw the FBD. Now the block is kept on the inclined plane, but we'll consider that those blocks act like a horizontal body. So for that, we'll first draw the bottom most block, that is block A. Now this block A will move down. So I'll give the direction of motion here. This is the motion of block A moving in the downward direction, right? So whenever we draw the FBD on the inclined plane, draw the normal friction force, then the applied forces, if any, as horizontal and vertical forces. The only inclined force when we make it horizontal, it is a weight force, right? So only weight force becomes the inclined force here. So first we'll draw here the normal reaction. So for that we'll consider this is the normal reaction. We'll call this as N1. Then we'll draw the friction force. So we'll change the color. Body is moving in this direction, so friction force will always act in the opposite direction to that. And the value of friction force is equal to mu, that is 1 by 3 into N1. This is the value of friction force. As this block is moving in the downward direction, this block B will not move along block A. Only block A will move in the downward direction. So there is a friction along this surface also that we have to show. So for that we can show the normal reaction here. So it is vertical in nature. Normal reaction is always pointed towards the center of the object. We'll call this as N2, and block is still moving in this left direction, so the friction force will act towards the right direction. So this is the friction force. It is horizontal and its value is 1 by 3 N2. Now the most important thing is showing the your weight force. So for that, draw one horizontal line here, one vertical line here. So as you can see, weight force lie in the third quadrant. So here also we can similarly consider the horizontal line and the vertical line. So weight force is a inclined force, so it lie in the third quadrant, right? So its value is equal to mass of A is given 40 kg, so 40 into 9.81. So this value is in Newton, okay? Remember this value is in Newton. So here we'll draw its horizontal and vertical component. So horizontal component will point towards left direction and its vertical component will project in the downward direction. So this is 40 into 9.81. Now see, the angle theta of the slope, it is identical to this angle with y-axis. So considering this as a special case, we can write the horizontal component is equal to 40 into 9.81 into sine theta, and the second component is 40 into 9.81 into cos theta. Why we have written sine theta and cos theta? Because the given angle is with respect to y-axis. It is not with respect to x-axis. That's why we have written this angle, right? So this complete the FBD for shape A. Now we can concentrate on the second block B. So we'll draw it here. This is our second block, which is block B. So we'll write it here. This is block B. Same way, just like this, here we'll have this normal reaction. This is normal N2. This is exactly opposite to this one, and friction force will be exactly opposite to that also. Okay, so friction force will be 1 by 3 N2, opposite to this reaction. Then there is a tension connected here, cable is connected here, so we'll show the tension force here is the tension force. And similar to this, we'll show the weight force. Draw the coordinate system. Similar to this weight, this will lie in the third quadrant. The value of the weight force is equal to 13.5 in kg it is given, so multiply by 9.81, and this angle is theta. So simply we can write the value of x and y component of this will be, this is the x component and this is the y component projected downward. So it is 13.5 into 9.81 into sine theta. Remember, it is not cos theta, it is sine theta. And here it is value is 13.5 into 9.81 into cos theta. This way we can draw the FBD for figure A and figure B. Here we'll consider block B and we'll apply conditions of equilibrium. So first equation we'll write. So this is the block B. So T value is unknown. We can start with summation Fy here. So we'll write here summation Fy is equal to 0. So in this block, if you observe what are the vertical component, first one is N2. Next one is weight component, that is minus 13.5 into 9.81 into cos theta. These are the only vertical component in this equation. So here N2 value we get, N2 is equal to 13.5 into 9.81 into cos theta. This value we get after using first equation. Then we'll consider block A, because writing fx equation will not give any value for the block B. So we'll move on to the block A. Here also we'll use summation Fy is equal to 0. So in this component, if you see, this is block A. Vertical forces are N3, 40 into 9.81 cos theta, and N2. So we'll write as per that. So here the components are N3, N1. Next one is minus N2, then minus 40 into 9.81 into cos theta. So it is equal to 0. Here N1 value is unknown, but N2 value is known. It is 13.5 into 9.81 into cos theta minus 40 into 9.81 into cos theta, it is equal to 0. So here N1 becomes, N1 is equal to 13.5 into 9.81 into cos theta plus 40 into 9.81 into cos theta. This way we get the value of N1. So using block B, we have calculated the value of N2. Using block A, we have calculated the value of N1. Now we'll focus on finding the remaining value. That is, our main objective is to calculate this theta. So we will see how we can achieve that. So we'll apply the third weapon that we have. So for block A, we can write summation Fx is equal to 0. Now see what are the horizontal component here. First one is 1 by 3 and 2, it is positive. Next one is 1 by 3 and 1, it is again positive. And the last factor is 40 into 9.81 into sine theta. This is the horizontal component of the weight force, so that we can utilize here. So here we can write, starting with the equation. I will change the color so it will be easy for you to understand. 1 by 3 n2 plus 1 by 3 n1 minus 40 into 9.81 cos sine theta is equal to 0. This is the simple equation of this, right? So by rearranging this equation, taking 1 by 3 common here, so here 1 by 3 n1 plus n2, so it is equal to 40 into 9.81 into sine theta, right? This 1 by 3 goes here, so it get multiplied. So if you don't know how to find these equations, you can watch our video. I have made a dedicated video on this thing. So 3 into 40 into 9.81 into sine theta. Now this is the equation. Now we have got the value of n1 and n2. So we can put those values here to get the final answer. So here we can write, after putting the values of n1 and n2, we can write n1 value is 13.5 into 9.81 into cos theta. You can simplify it, plus 40 into 9.81 into cos theta. This is the value of n1, and the value of n2 is plus 13.5 into 9.81 into cos theta. This is the value of n2. Okay, so it is equal to 3 into 40 into 9.81 into sine theta. This is the equation. So here you can observe that 9.81 is common everywhere, so you can cancel out 9.81 from all the equations, right? So we get the final equation as 13.5 cos theta plus 40 into cos theta plus 13.5, it is equal to 13.5 cos theta, it is equal to 3 into 40 into sine theta. This way we get this equation. Now few steps are remaining, so I'll erase the data which.
A few moments later.
So after this equation, we can take out the common term, like cos theta is common here, so we can take out the cos theta common from the left side, so it becomes 13.5 plus next term is 40 plus next term is 13.5 into cos theta. So it is equal to 3 into 40 is 120 sine theta. Now to get the value of theta, we should either find tan theta or cot theta. So for that, we can take this term cos theta here. Now this cos theta is multiplied here. So when it goes to the other side, it should divide the other side. So we can write this as 13.5 plus 40 plus 13.5. It is equal to sine theta divided by cos theta, right? And this 120 is multiplied here, so when it goes to other side, it will divide the other side, so it is divided by 120. Now this sine theta by cos theta is equal to tan theta, right? So we can find the value of theta as theta is equal to tan inverse of remaining term, like 13.5 plus 40 plus 13.5 divided by 120. This way, by taking the inverse of this term, we can find the value of theta. So you can find the value of theta and write it in the comment box. So by this method, we can calculate any required value for the given question related to the inclined plane. So remember, for the inclined plane, most important thing that the given force, friction force and the normal reaction will act like horizontal and vertical forces. So only inclined force here is a weight force, and the angle of weight force with the x-axis will be 90 minus angle of the slope. So by using this method, we can solve difficult question and make it simple. So you can easily solve them and score good marks in the final exam. If you find this video helpful, you can like this video, subscribe to our channel. Thank you. Thank you very much for watching this video.